Paul Douwes is the North American Sales and Marketing Manager for Advaris, an international software and consulting company based in Germany. He's been involved in the wire and cable industry for more than 20 years and brings his knowledge of the industry function and process to enterprise planning as well as manufacturing execution systems.
Well, I want to thank the Wire Association for the opportunity to present today. My title, my presentation is Connect Smart Factories and Length Measurement. This, of course, is a very large topic, and I wanted to focus on the connected parts of how to become a smart factory. It's been a pleasure to hear various vendors and suppliers to the industry whom presented their various solutions for the industry. However, it's very important, of course, as a factory to have the entire operation in sync. So first of all, just quickly, what is a smart factory? This is a definition that I have found that I feel fits quite well for the industry. The smart factory is defined as a factory where physical production processes and operations are combined with digital technology to create a fully integrated, collaborative manufacturing systems that respond in real time to meet changing demands and conditions in the factory to create an advantaged value. So that's quite a mouthful. Basically, what we drill this down to is that a smart factory needs to have what's called a digital twin and a digital thread. In order for it to be truly smart, we have to have the full factory digitally in place. A digital twin is described as a virtual replication of an as-designed, as-built, and as-maintained physical product, augmented by real-time condition monitoring and predictive analytics. So in other words, a true smart factory will have the entire factory process with digitized so that the operators, the managers, the maintenance personnel all have the ability to see the factory not only in real time, but also before any manufacturing even happens, so that changes can be replicated, processes can be developed, proper scheduling can happen, and your factory can adjust depending on real-time challenges that come, as we know, in length measurement. A digital thread is explained as an accompaniment of the digital twin and is a repository of product-level information, such as performance data, service record history, parts identification information, technical manuals, how-to videos, and much more. This digital thread, of course, is necessary to have available so that anyone working within the factory can be making proper analysis and decisions as they move forward in real-time operations, as well as making changes for the future within the company. So achieving digitization through connectivity. Connectivity can happen in a lot of various ways, and I wanted to share with you some of those insights. You, of course, have seen many of these even throughout the presentations. What we find is that the operation is run with what we call a shop floor control. This shop floor control has the ability then for machine and process data capturing. At the very top, you'll notice the term PLC. The PLCs are connected directly to machines within your operations that can connect directly to the Ethernet. There's a new technology that has been developed over the past number of years called OPC Server technology. The OPC Server is a software program that converts the hardware communication protocol used by a PLC into the OPC protocol. The OPC client software is any program that needs to be connected to the hardware. The OPC client then uses the server to get data from or to send commands to the hardware. Very interesting is that the OPC server can read any number of types of signals. We just need to know the names of those signals. Of course, you will find that once it's through the OPC server, those signals are read, and then it moves on down the chain. Of course, not every machine will be new and have a PLC, and so there are many ways that you can connect to the factory. You can connect with a field bus system. You can connect through an embedded PC with digital or analog signals, as well as signal converters. And so any device can be connected within the entire plant, run through either an OPC server or an embedded PC, and then through the Ethernet will reach the MES server. So the MES server is where all of the data is collected, and also where the data is real-time placed within the operations, filling fields such as your quality data, your real-time speeds, your heat sensors for your temperature zones, as well as the line speeds, the completion of orders, all the details for all of your operators, etc., and etc. You will find that the shop floor control can easily be connected to all of your measurement devices. These measurement devices can be supplied from various types of vendors, of which some of them we heard of today. From this, we can do online capturing of measured values. We can also achieve automated validation of test results, connecting directly to the laboratory. We can also have nonconformity reports. This can also be sent directly to management via alerts with a text message, an email, or even an alarm. And also we can achieve test certificates, which can be populated with real-time data. Another key element to a connected factory is the fact that we can have a paperless plant. So once the machine operator selects the next production order and starts the machine setup parameters, the recipe parameters are automatically transferred to the PLC. And due to the fact that we are still connected, that order is processed through the MES server from the terminal. And so your operators will always have at their fingertips not only everything to do with that production, but also the recipe parameters for the cable. Again, another interesting dynamic that has happened within our industry is the amalgamation of technology. In the past, it was necessary to utilize other technologies in order to achieve full connectivity. And now we have moved to a point where MES and SCADA can be connected, and so they can be supplied from one vendor. This is, of course, a great cost savings and also savings in time and dynamics in working with various vendors. And so the SCADA will produce the results that you need real time on your shop floor, and of course populate the MES where necessary throughout your real-time data. Now, what does a smart wire and cable factory look like? I've got a slide next that talks a little bit about what that can happen. Truly, a smart cable factory not only is run by people, but also has some self-regulating processes. And so we can find that because we are fully connected, the processes can initiate various alerts. They can also set up the factory for making changes in process. So first of all, we can look at the quality control. So when the manufacturing is in process, of course, we have our measurement devices connected in real time. Because we have that, the devices are determining that a wire die is moving towards its lifespan, and so an alert will come up for the operator or the maintenance department, depending on what has to happen, so that a new set of dies needs to be placed. The next area is the scheduling, and the MRP. The system can automatically generate alerts such as machine breakdowns during operations. It can, with of course some support from the scheduling operators, to reschedule via the alternative routings that the system can determine. Also, in regards to alternative, the system can determine via the operator that the materials are stocking out, and so very quickly the system can come up with alternative compounds or various raw materials that can be reworked. In addition, as the operations are in process, automatic transportation orders can be generated, moving, for instance, raw materials or moving from process to process. And of course, the last area is the maintenance. Can be alerted, and obvious is for machine breakdowns, but also can request maintenance staff for various jobs within the factory, and can be alerted for predictive areas. So these orders can be generated with various signals that we can find from the PLC, such as a bearing that is wearing out, vibrations that are too strong, heat sensors that are determining that the temperatures are rising too fast or that they're too slow. And so all of these self-regulating processes can be working not only in the background, but in conjunction with your factory. This slide just shows a little bit about the MRO, which is a module for maintenance. This solution, because we are connected to the entire factory, will be able to enable this condition monitoring. The monitoring maintenance compliance will happen so that activated plans and orders will be generated. Everything will be time-stamped. You will have a handle on the amount of spare parts that are within the factory, and will also produce all of the tests, the videos that go with the actual maintenance. These alarms can be automatically generated to the maintenance staff as well as the support throughout the factory. Repair requests will also be generated, and purchase orders can also be automatically produced. So as I complete and move throughout this presentation, I wanted to highlight a few of the wire and cable pain points. Of course, we can talk generally about the fact that we want our wire and cable factories to be connected, but there are a lot of reasons why this can surely benefit a factory and move a factory to the next step in being a true smart factory. So the wire and cable pain points resolved, how a smart factory performs. So we have a number of challenges, and then we have some solutions. One challenge that we find is that within our operations, we have fluctuating metal prices. These prices, as you know, can change dramatically even within the hour. And so we need a system that's smart, a system that can, in real time, produce those customer-specific billing details according to agreements. And so as the production is happening, or as the cable design and sale is happening, these prices can be automatically populated throughout the process with a smart factory. Another area that we find is a big challenge is costing based on various lengths and drum sizes. As you know, we have customers who are looking for many different options, different lengths, as well as options for different sizes of spools or reels that are delivered. And so we can then very easily, because we're connected to the entire factory, come up with offer pricing per individual length, including actual metal, drum, and cutting costs. And so the actual cost can not only be delivered very quickly through these tools, but also because we're collecting all of the real-time data, we're able then to go back and adjust any of the preset determining fields so that we're even more accurate as we move forward as a factory. Another challenge is the production scheduling in respect to individual lengths, drum sizes, and constraints. Production scheduling in the wire and cable industry has many challenges. This we know of. Challenges like multi-wire drawing, items like degassing, challenges with startup lengths, breakages, of course, machine downtimes. Because of all of these things, we need routings that are complex and to build out real-time schedules. And so a smart factory has algorithms and rules for the process built into planning. Another area that is a challenge is bottlenecks in manufacturing. And of course, because we find that we have bottlenecks, we need to have alternative routings based on machinery capabilities and materials. And in order to do this, we need a look-ahead strategy, a system that is smart enough to look at various work in progress and production so that certain orders can be paused in order for the production to catch up. An example would be an insulation line that is putting together drum sets for the assembly. And it makes sense that the assembly would not start until there's enough drum sets in place for that process to run continuously. And so the system will know with this look-ahead strategy on how to, in real time, have scheduling so that you have continuous production at all times. Another area that's a challenge is traceability. traceability not only for the finished product, but for each individual length that is produced. The way that that can be done, of course, is the fact that we have complete historical data stored for each length. And that is for all aspects of manufacturing. Everything from the material used, every component that was used for the manufacturing, the operator data, various gauges that have tied in, such as temperature, speed, brakes. We know exactly which die sets were used. Every single aspect of that manufacturing is stored and recorded and tied in with that length. And so full traceability can be had. We can find out exactly what was put into a length, as well as we can find out how many different lengths were impacted by individual details, such as the raw copper. We can discover exactly how many lengths were impacted by that coil. And lastly, as a challenge, this of course isn't a full and complete list, but the cost variations and profit goals while trying to be competitive. Of course, wire and cable industry is very competitive. We have companies all over the world producing cable. And so the goal is to minimize setup times and scrap savings. This, of course, is not the complete way to have full cost savings, but it is a major part of how we move forward. And so the system needs to be able to very accurately and quickly minimize setup times and eliminate as much scrap as we can by having a very accurate scheduling, as well as an accurate system by which to measure any challenges with quality so that we can reduce the scrap. This then is tied in with full plant scheduling and is based on the cost savings. So to finish, I wanted to highlight the fact that a perfect plant is the ideal. And at Advaris, we do have the best practice ERP and MES solution for a wire and cable operation. And you'll see in this diagram that we do not only have one area that we support, but we do support every single part of the wire and cable operation. In fact, what we like to talk about is the full cycle, the full life cycle of a cable, right from the sales to the design, through the product data management, to the warehouse management, the production order, the detailed planning and scheduling, shop floor control, quality control, and maintenance. And so with that, I'd like to conclude my presentation and would be open for any questions.
Thanks for the comprehensive presentation, Paul. It was quite detailed. We do have a few questions. Does a factory need all operating equipment for each terminal with scanners and touchscreens for each operator for an MES to work properly?
Yes, thank you. That's a great question. Factory does not need to have separate touch screens for every operation. There, in fact, can be one terminal which can handle a number of operations at once. Basically, you need any type of computer to operate, and we can use various tools that a factory might have, or they can purchase some state-of-the-art technology for scanning as well as entering data.
Okay. Do you see this approach as something that has to be done as part of a major project, or could it be done piecemeal over time for a company maybe reluctant to do everything up front?
Sure. A complete implementation does take a significant amount of time and resource. And so the Advaris solution is split into modules. And so we can take the factory a piece at a time, for instance, starting with the cable design and then moving towards the manufacturing execution. Modules such as the maintenance can always be added afterwards, as well as the full module that we have for your warehouse management. And so it can be done in pieces in case of challenges with budgetary constraints.
Mm-hmm. There's been a lot of talk about Industry 4.0 and the smart factory, and it's always seemed like it's something to come. And there's periods where it's getting more momentum and it seems slower. But the reality, do you see it actually coming into its own? And with the technology you guys offer playing a part in that eventually? Is it going to be the way?
Yes, the reality is that every single wire and cable company will need to achieve full capability and achieve the best cost and margins that they can have. This will only happen with full digitization and understanding how to move forward to be at that complete smart factory. This can be done over time, and many factories achieve great success by using existing tools such as Microsoft Excel for their planning. However, to truly move forward to achieve a factory that can have complete scheduling control as well as full traceability of a high functioning manufacturing execution system will be necessary.
Do you think the biggest challenge is the technology or human nature?
There is some challenges with human nature, of course. We have technicians who like to do things a certain way. Some of them have many workarounds that will be difficult for them to adjust. They also have ways that they can work at the pace that they determine. And so these are some of the restraints that we do see in the implementation. However, having this full traceability means that the entire plant is accountable, and so that operators, managers, and purchasing all can have the same perspective on where the plant is moving and how you can achieve a full, complete, functioning, smart plant.
Yeah. The final question. It just seems like the industry has always had people reluctant to be the first, or sometimes the second or the third. There's a lot of companies maybe just on the sidelines. What do you think it will take for them to really sit up and say, this is happening?
Well, what we're doing at Advaris is up with some very good customer-specific reports so that companies can see in the results that are happening. But ultimately, it will come down to companies realizing the fact that they need to at least look at the possibilities. And this can be done very painlessly by a presentation and an online demo to see what the opportunities are for their factory.